So now remember we had the difference and some identities. Now you can manipulate those and be able to create a new set of equations, right? So let me give us an example. So for example, if we have sine A plus B, right? Then this one will give us sine alpha, sine A rather, sine A cos B. And remember this is plus. Then we are going to have cos A, and then we'll have sine B, right? So now if we get the other, because remember I had emphasized that we needed to know these ones, okay? Now if we go on and get sine, right? We get sine A minus B, okay? We're going to have a similar situation here where we have sine A, and then we'll have cos B, then we'll have minus cos A sine B, right? So what can we do here? We can add these, right? If I add these, these are similar, so these are going to cancel, right? So we'll have sine A, okay, plus B, then plus sine A, right, minus B, like that, is equal to, these are similar, so they'll add, then they'll become 2 sine A cos B, like that. Then I can solve for this statement here, right? So it will become sine A sine B. I think we should be very good with algebra now to know that this will divide the other side instead. So then we'll have a combination of these two, sine A, right, plus B. Then we'll have plus sine A minus sine B. Now you're going to see that this is actually a product of sine functions, and then this will be what it gives you, right? A plus B, right? Remember, this one gives us cos like that. A cos B minus sine A sine B. Okay, then we can go on and say that we have cos A minus B is equal to cos A cos B plus sine A and sine B. You'll notice that if we just simply add these two statements, these two are going to cancel out. So meaning that we'll have cos A plus B, then plus cos A minus B is equal to 2 cos A cos B. Meaning that this can be made, we can solve for this, right? So we'll have cos A plus cos A, and then cos B equal to half. Then we'll have cos A plus B, then plus cos A minus B. Right. So this is how you work out this product to sum. Remember, we had sum and difference identities. Okay. Then now we have product to sum. All right, so what are these product to sum? Let's list them out. So we'll have product to sum. You saw how we actually derived this. So here we're going to list them out now. So product to sum, we're going to have the first one, sine A. You saw how we derived, and the rest can also be derived just like this. Right, so we'll have half, and then we have cos, right, alpha for A minus B. Then we say this, we take away here cos alpha plus beta. So by the same method, we can also create this one, that one, and this one. Right, so we're saying sine A, sine B is half cos A minus B minus cos A plus B, right? Then cos A cos B is equal to half cos A minus B plus cos A plus B. So these are identities that we have to know and remember. So these ones we call product to sum. Right. Let's look at the next one that we call sum to product. So remember, we have to remember the path that we're taking. One is difference, sum. Then second, remember we had the basic one. So we say zero basic. Those are the tangents, the other ones. Then here we have the difference or sum. You remember that we had something like this that gave us the difference. And then something like that gave us the sum. So I'm sure by now you know these. Right, so we go to number 2, which is going to be, we said that it's product to sum. So how do we recognize this? We see that this is a product, and then it's given us a difference, or it's given us a sum there. Okay, so but they call them product to sum or product to difference, depending on where you are